Welcome to 5.4 Other Proportionality Theorems. So this is proportional parts. The first theorem we're going to start with is the side splitter theorem. The idea here is if a line is parallel to one of the sides of the triangle and intersects the other two sides at distinct points, then these sides, it cuts the sides into proportional lengths. Meaning here BF is to BC is the same as BE is to BA. We're going to use this in example here. The idea is that the parts are proportional and we can set up a proportion. Right. 12 is to 4 is 15 is to x. Cross multiply, we get 12x equals 60, so x equals 5. Sometimes we need to cut this into parts or to add or subtract in order to find everything. If we're setting up a proportion here, 8 is to x as 4 is to the whole length 7. 4 plus 3 is 7. Cross multiply here, we get 4x equals 56, so x equals 14. A corollary to the first theorem is that if you have 3 or more parallel lines intersect two transversals, then they cut off the transversals proportionally. The idea here is they don't have to actually be triangles, just 3 parallel lines. It's still proportional. 5 times 2 is 10, 6 times 2 is 12, so our scale factor is 2 there. So our example here, we could set up it multiple ways, but 3 is to 2 as x is to 4. Cross multiply, we get 2x equals 12, x equals 6. Next example, 8 is to 3x plus 9 as 6 is to 18. Cross multiply, we get 18x plus 54 equals 144. Subtract 54, we get 90, divide by 18, and we get 5. Our last theorem is called the angle bisector theorem. If an angle bisector in a triangle separates the opposite side into segments that have the same ratio as the other two sides. So we can set up a proportion here. 9 to 6 is 3 halves, 12 to 8 is 3 halves. So our proportion we would set up is 10 is to x as 15 is to 6. Cross multiply, we get 15x equals 60, so x equals 4. In this one, we'll have to subtract to find the length of the side there, which is 4. So 3 is to 2 is 2x minus 10 is to 4. Cross multiply, we get 4x minus 20 equals 12. Add 20, we get 32. Divide by 4, and we get 8. So that is other proportionality theorems.